In 2012, Japanese physicist Fusa Miyake was working with Japanese cedar trees and carbon-14 and other isotopes for her doctoral research and discovered something quite strange that would go on to become quite disconcerting for something we've known about only just over a decade now. The initial research identified the first of these events, now known as Miyake events, in the Japanese cedars through carbon-14 dating, traced approximately to the years 774 and 775. That initial event was puzzling, and to this day we are not 100% certain what exactly caused it, though a strong contender for some of them seems to have originated from something going on with the sun, more on that in a bit. Only that a burst of cosmogenic isotopes were created by some kind of astronomical event through cosmic rays hitting Earth's atmosphere. Since this initial detection, more have surfaced. In 2013, Miyake identified another one centered on the years 993 and 994. By 2023, 6 separate Miyake events have been isolated through mainly tree ring and isotope studies involving carbon-14, carbon-10, beryllium-10, and chlorine-36. All produced similarly to carbon-14 in Earth's atmosphere under cosmic ray bombardment. The initial suspicion for the creation of those cosmic rays was high-energy supernova events, and that may well be the case for some of them, but it soon became evident that a very good candidate for these rays were solar storms of an apocalyptic strength on a level we have not seen while we've been able to monitor those phenomena. Other Miyake events are traced to the year 660 and 5480 BC. These things have regularly occurred for as long as we can measure tree and ice core samples, and on moderate timescales are not rare, possibly to the point that we may actually be overdue for another such event. Oddly hidden within this story is an odd quirk of cross-disciplinary benefit in science overall. Where Dr. Miyake is a physicist, the work actually proved to be of great benefit in an entirely different field, archaeology. Dating objects in archaeology, particularly carbon dating, is problematic. It would actually be very difficult, based solely on carbon dating, to differentiate World War I, starting in 1914, and World War II, starting in 1939, if they had happened a few thousand years ago. Even though we know from history how significant those two events were, if you don't have the history, archaeologists probably wouldn't be able to tease out any details based solely on isotopes. It's usually too general. But it has to be said here that the artifacts themselves would tell the story. Those two wars saw very different levels of technology that would even be evident based on strata in the soil, design, and so on. The point is, archaeology can date to about half a century, 25 years in really good conditions, but not precisely to the year, with isotopes. Except with the Miyake events. Those may in some lucky cases allow for things to be narrowed down much more precisely. Case in point, the Vikings. It was known that sometime around 1000 AD, the Vikings landed in Newfoundland, in North America, and maintained a presence there for a time. But none of that could be narrowed down other than approximate dates, very approximate. A pair of archaeologists came across Miyake's work, presumably in the literature, and they were able to take measurements of logs felled by the Vikings for their settlements. Most of them were normal as far as carbon-14 and couldn't be precisely pinned down to a year, but one log was different. In a single ring, an isotope spike from the Miyake event of 993-994 was seen. From that, all they had to do was count the rings past it out to the edge of the log, and they had their date. The Vikings cut that tree down in the year 1021, and in archaeological context, that's likely to be the year they first landed. All this from an event that happened in space that the Vikings had no idea even occurred. One has to wonder if we were able to transport one of those Vikings here from the past, or were able to convince the Viking not to come at us with a battle axe because of our strange dress, language, and customs. They might still come at us with the axe for knowing a bit too much by looking at logs about when they precisely landed in Newfoundland. I could put a VPN commercial here. It's the perfect spot for that, but I shall refrain. But the possibilities go well beyond that because there are any number of archaeological sites that might line up with a Miyake event. That if the archaeologists can find wood samples and spikes within them, then they might be able to constrain all sorts of information, all the way to understanding how some ancient calendars line up with those of today. But all of that may not matter very much, because if a Miyake event were to hit today, there may be no counterpart civilization left capable of studying the isotopes of tree rings. The biggest thing we've seen from the Sun is the infamous Carrington event of 1859. It's the largest geomagnetic storm seen since we started recording them, and it was the result of a coronal mass ejection hitting Earth's atmosphere, something that happened recently, treating many across the world, including myself, to intense auroral displays in areas that do not usually see them. Carrington was so strong that it caused sparking, and apparently even a fire in one case, in telegraph stations. It is well known that if an event the size of the Carrington event were to happen today, it would cause massive disruptions to the electrical power grid and wreak havoc on unprotected electronics. We'd recover, but it might take a year and would cause unprecedented global disruption for some time, and potentially even civil unrest. But here's the problem. Carrington was not strong enough to have been a Miyake event. In fact, it wasn't even close, causing only a barely perceptible blip in tree rings. The fury of the Sun cannot be overstated here. While such things aren't going to pose a large-scale physical threat to humans, though just imagine the auroras they saw during these events, but they would be devastating to our electrical grid. Think of it in these terms. The Hiroshima atomic bomb released the equivalent of 15,000 tons of TNT, some estimates a little more at 16 kilotons. This is where this gets spooky. The power of the Carrington event, as far as energetic equivalent, is 660 billion, with a B, Hiroshima bombs. As staggering as that is, the Miyake events centered around the years 774 and 993 were both 5 times larger than the Carrington event. And they weren't even the biggest ones. Another event from 14,000 years ago was twice the size of even those. That's 6.7 trillion Hiroshima bomb yields in energy. Though bear in mind that these are solar storms, not atomic bomb blasts. There were no blasts here, just a lot of energy around. The electrical disruption of something that size is almost beyond fathomable. Our satellites, power grids, electronics, and so on would not survive that. I'm guessing there are ways to shield that. There are, but doing that on a large scale against something that powerful is beyond a challenge. And we don't even know if there are any warning signs from the Sun regarding events this large. All we know is that we have solar cycles and increases in sunspots that tend to herald solar storms. As an aside, this may actually be a viable solution to the Fermi paradox, at least in part. So it's becoming increasingly clear that gigantic solar flares and storms from red dwarf stars is growing increasingly likely to be a showstopper at this point for alien civilizations, unless certain conditions are met within those star systems, such as selective, directional flaring that points away from any planets in those systems. Otherwise, the exoplanets just lose their atmospheres, something that so far seems to be the case with TRAPPIST-1 and its planets, but only 2 of those have been measured so far. The next measurement is the important one, however, and that has not been published yet. But if it shows no atmosphere, then that's probably it for red dwarf systems other than special cases. Type K stars, we don't know. They are much quieter and may allow a way out for alien civilizations, negating the solution. But if something turns out wrong with all of those, that leaves Type G and Type F. Type F isn't as good because those stars don't live as long as the other types, and they are heavy ultraviolet emitters, but they're still on the table. Type G is the Sun, and it may actually be the most insidious type. If the Sun can periodically wipe out technological civilization, we haven't been here long enough for one of these events yet as an industrial technological civilization, then we live around a periodically extremely violent star that does not preclude biology, but does preclude technology if a civilization doesn't act fast enough to mitigate Miyake events, if they are something that is common to all G-type stars. You either have time to build some kind of solar shade, or you do not. And so far, the Miyake events on Earth seem to happen at average rates of 1 every 400 to 2400 years. These kinds of events are seen happening at other sun-like stars. They are known as superflares, and it appears that the sun is capable of them. And like a ticking time bomb, it is not a matter of if, it's a matter of when. So what would happen if one of these hits today? Well, you'd be physically okay on the surface of the Earth. The atmosphere protects us very well, and these events do not seem to have ever caused any mass extinctions or anything like that. But where you do not want to be is in a spacecraft or space station. This level of an event would probably be fatal no matter what, and even in commercial airlines, you would be in danger of a very high radiation dose, possibly even fatal. The global power grid would almost immediately collapse, leaving much, if not the vast majority of the Earth without electrical power, very likely long term. It may not be so easy to manufacture what would be needed to repair the grid after an event like this. That said, this threat is actually something like the threat of an asteroid. There are ways to mitigate it if you know about it ahead of time. Scientists working with Miyake events are working very hard to understand if there is a predictable cycle to them, or some kind of advanced warning such as the sunspots. If we know ahead of time, then bring the astronauts home in an emergency situation. Ground all flights, shut the satellites and communications systems down, shield the electrical grid and shut it down, and that's only if all Miyake events originate from the sun. They may not. They may also be produced by astronomical events for which we have no warning at all. Supernovas may produce them if close enough, and even events like gamma ray bursts that we do not have a full understanding of, and aren't likely to ever have much predictive capability regarding them, basically relegating us to eventually protecting the planet using orbital physical shields. Doable, but not quite yet. Every so often, my spooky videos on this channel move from spooky to scary, and this is one such video. Thanks for listening. I am futurist and science fiction author John Michael Godier, and after that, I'll just say check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.